Thanks to everyone for attending my talk today. I'm Neeraj Tolia, and I'm going to be talking about data protection in a Kubernetes native world. For those of you who don't know me, I'm the co-founder and CEO at Kasten. We are a startup based here in the Bay Area and in Utah, in Salt Lake City. And we focus on Kubernetes native backup and disaster recovery. Personally, I've been using Kubernetes since 2015 or so, but that's when my first customer-facing application went live on the platform. So the pre-1.0 days. But generally speaking, my industry background has been in storage and data management and an academic life before that. A lot of patents, a lot of papers in the area, but most importantly, this is my third SNIA Storage Developer Conference talk, and I'm very excited to be here. In terms of my professional history, before I started Kasten, I used to be a part of Dell EMC's data protection group. Previous to that, at a startup called Magnetics, we did distributed file systems. We got acquired by EMC. We used to be at HP Labs, where I worked on next generation storage. And then at Carnegie Mellon, where for my PhD, again, I worked on deduplication and storage systems. So you could say storage data is in my blood at this point in time. That said, today we're going to be talking about Kubernetes. If you're not familiar with what Kubernetes is, if you are running applications that are deployed within containers today, it is by far the best platform to deploy them on. It will help you with deployments, with scaling of your application, with management, upgrades, updates, etc. The goal of the talk today is not to focus so much on Kubernetes, but given the conference, we're going to look at briefly as to where Kubernetes is today. Why is it important? Why should we all care about it? Where it is heading, and in particular from a storage point of view, what is happening within the ecosystem, why databases, NoSQL systems are blossoming in this environment, and then finally, what we need to do to protect it, what has changed, what's different now. Why do legacy VM-based solutions not work? We're going to focus on a lot of those topics over the course of the talk today. Now, to kick things off, the thing that I strongly believe in is that Kubernetes is the next wave of infrastructure. The last similar wave that I had personally seen was the growth of virtualization, the growth of VMware. And we're seeing that same thing happening for the container ecosystem today. When you go look at the cloud native computing foundations landscape, it seems very crowded. A lot of people doing a lot of things. But this is the strength of the ecosystem. This is where this ecosystem has succeeded, where OpenStack tripped up a little bit. And while it might look a little noisy, the important thing here to remember is things are shaking out, and we'll talk a little bit about that too. Overall, Kubernetes adoption, still early days. We're at the beginning of the hockey stick curve, but it feels like it's growing very quickly. Even for early users, when people looked at folks running containerized workloads on Kubernetes, roughly 60% were running them on Kubernetes. The other ones might have picked some other platform to begin with, and then are migrating over. And still roughly 60% also running fewer than 10 Kubernetes clusters. At the same time, in the same survey, roughly 60% of people were running Kubernetes in production. And 20% of those that were running in production had 50 or more clusters. That's something we see that's very different in this environment, where people tend to be multi-cluster, sometimes split amongst applications. And while this might again seem like it's early days, the length of time to standardize on Kubernetes, according to 451 research, is actually very small in the grand scheme of things. In the next 3 years or so, we expect to see roughly 70% of folks standardize on Kubernetes as the container platform of choice. When you look at absolute numbers, they're very high. This ecosystem is driven by developers, is driven by DevOps, and the most recent data set that there are roughly 6.5 million cloud native developers that are driving digital transformation across a variety of industries today. And out of these 6.5, roughly 2.7 million are running applications on Kubernetes, interacting with Kubernetes on a daily basis. And so this is something to keep in mind as to how the growth of the ecosystem is tracking and why we should all be paying very careful attention to it. That said, as the ecosystem is maturing, What people call day one is winding down. This is the initial challenge of provisioning and installing Kubernetes, how to roll out upgrades. You see this in the ecosystem, you see companies consolidating, such as the recent acquisition of Rancher by SUSE. But the focus now, as people have gotten more comfortable with the platform, is that day two is the topic of conversation. Essentially, how do I operationalize this? How do I provide a common foundation and platform for my entire enterprise, for my entire company? And some of the important topics that are being discussed now include things like data management, the focus of today's talk, but security, observability, etc., which are critical as more and more apps get onto this platform as self-service becomes important. And in the particular area of data management, we definitely see this as an exploding day two use case. But sometimes people have questions, and there's this half-life, there's a misperception of, is Kubernetes really ready for stateful applications today? And it is a firm belief that it is, but don't just take my word for it. When you look at Sysdig's survey from last year, for their customers of the Kubernetes clusters they were monitoring, roughly 50% of them were running stateful applications. 57% of these clusters were running stateful sets, which is a Kubernetes construct to run databases, NoSQL systems. And when you look at it from across the board, pretty much every storage vendor out there has Kubernetes integration built into the product. So last I checked a month or so ago, 70 plus storage vendors had support for Kubernetes. And when we go look at data from this year, it's even stronger. 451 research in a survey they did, looking at enterprises, found that over half of the enterprises that responded to the survey indicated that over half of the applications were stateful. And when you dig into what kind of stateful applications exist in this environment, it's actually a mix of many different things. We see batch and streaming data, we see NoSQL databases, we see relational databases, we see message queues. So it covers the span. There's a lot of diversity, which is good because the platform can support more than one kind of workload, whether they be very large or very small. So in the rest of this presentation, we're definitely going to talk about data protection for Kubernetes, what that means, what to focus on. But one thing I would like to add is everything I'm going to talk about is colored by shifting roles in the organization. Things like Kubernetes are not just about technology, but also about culture. They're about how an organization is run, how it pushes applications, how it achieves greater velocity. And that means different changes in the org. And we're going to see that as we walk through the rest of the stack. Now, at the very high level, some of the core problems haven't gone away. Same things that existed in your bare metal environment, that existed in your virtualization environment, are still issues today. When you talk about use cases such as backup and recovery, application mobility, disaster recovery. But the way these features or use cases are surfaced has changed a lot. Given the self-service nature, multi-tenancy, role-based access control into data management and backup into disaster recovery is extremely important. Disaster recovery in particular is more complicated now. Kubernetes runs not just in a multi-cluster environment, but across different clouds, across regions and hybrid environments. It's an on-prem presence, it's a public cloud presence, sometimes multiple public clouds. You have multiple data services in use, everything from managed services to things running within Kubernetes. And frequently you want to move your application around across storage systems, across clusters for upgrades, for performance reasons, for isolation. And we see a lot of this happening in the data management space. So we're going to drill down across all these use cases. First of all, we're going to spend some time looking at what's really different. And the first thing to think about is the deployment pattern of applications has significantly changed. Unlike your virtualization world, there's no mapping of an application to a virtual machine anymore. So you can't just simply protect a virtual machine and say, I'm done. Because that doesn't mean anything, as you'll see in a couple of slides. There's dynamic rescheduling happening as the system will automatically try to rebalance load. We will see scaling as workloads and your load changes. The constant redeployments via CI/CD pipeline as applications are changing and developers are deploying multiple times a day, if not multiple times an hour. And finally, there's a lot of multi-tenancy in a cluster. So visually, if we were to look at some of these deployment pattern changes, and it's useful to contrast against virtual machine backup and seeing where that falls short. So in the old world, in the virtualization world, you had applications running in VMs with storage attached to the virtual machine. First of all, as soon as you add Kubernetes, whether it's running within your VM, whether it's running on bare metal, you've lost this visibility now because storage is attached to the containers instead of your virtual machine. And when you transition to microservices, the number of applications has gone up significantly. Rather, the number of application components has gone up significantly. We see a 100x blow up in number of things to track, to back up, to restore. So scale becomes an increasingly difficult challenge. And then finally, these containers or microservices will get shuffled around the entire cluster. So no single VM has any single application. And these things scale up and down. So you can't, again, figure out from the outside in what storage is attached to what application, or even where an application might reside if you don't have Kubernetes native integration. And then finally, as I touched upon earlier, and we'll dive into more details in a little bit, 95% of the resources that one's going to look at in terms of backup, in terms of restore, in terms of disaster recovery, are not present on disk. Examples include secrets or TLS certificates. They're now present and materialize in the Kubernetes namespace, but you don't see them as a part of storage level integration. One of the other big things that has shifted that we've already touched upon is that of scale. So what we see today in this ecosystem is, and as we just touched on, explosion in application components. So you need to ask yourself if my system that was designed for VMs and VM level backup can deal with the 2 orders of magnitude difference in terms of resources to track, filter, monitor. There's dynamic auto scaling, so your application is not static on a per hour basis, on a per minute basis. It could be scaling up and down depending on what it's trying to do. We often see multiple data services in use, often in the same application. The same app might use simultaneously a relational database as well as a NoSQL system. And making sure you capture this all consistently is a challenge. And finally, multi-cluster use. It is not unusual to see people running 15, 20, 50, 100 clusters in their environment. Some of these might be large, some of these might be small. And you again need a system that can scale up and down with this. And that becomes important, that it's not just about scale from a high scale perspective, but from being able to go from a very small footprint to a very large footprint and to do it dynamically. When we talk about application scale, what that really means is for backup and recovery, you cannot focus on the infrastructure anymore. You can't just think about what resides on disk in Kubernetes, what's called a persistent volume, and the application's claim for that volume or in the database. For true backup and recovery, you need to focus on the entire application. This includes things like networking, services, configuration, what Kubernetes calls config maps, registry information, service accounts, secrets. You need to gather all of this for a high fidelity app capture to be able to understand it. And then you need to abstract your underlying infrastructure. So if this app needs to move to another cluster in another region, in another cloud, you should be able to do so. You should be able to move it around if you have performance requirements, isolation requirements. And then finally, a secret here in Kubernetes backup and recovery is that if you do a byte for byte restore for an application you might have backed up 6 months ago, it might no longer work as you'd expect because APIs might have changed. Short-lived secrets such as a TLS certificate that's only valid for a few weeks might have expired. So you need to be able to transform these in response to API changes, seek expired information, and then be able to bring the application back up. So performing this coordination is critical as you deploy something. And it's good to see this in the context of a real customer. So we're going to talk about Super Stereo's use case. And we run there across multiple clusters, hundreds of nodes. This cluster itself has grown to over 100 nodes at this point in time. And hundreds of applications in a single cluster, multi-storage system, multiple storage volumes, multi-terabytes of data in use. And when you go look at these applications, they have on average over 100 components that need to get backed up. The larger applications tend to have over 600 to 700 components per there. And when we talk about teams, They're servicing all of this with very small ops teams. A couple of ops people are supporting over 700 developers. So any backup and recovery system needs to be 100% transparent to developers here. Use case diversity, people want one solution that can do backup, DR, and app mobility across clusters for them, and handle the diversity without requiring developer changes. So this one particular company runs everything from COBOL to Go in the same cluster, and relational databases such as Oracle to MySQL, Postgres, all the way to NoSQL systems such as Cassandra, Mongo, Elastic. And one needs to be able to handle all of this when we talk about scale in these environments. Related to this, as we touched upon with the small DevOps teams, the other thing that we see with DevOps is the notion of shift left with things moving closer to the developer. So first of all, why Kubernetes is successful is because it's focused on the developer and the application and not infrastructure. Any backup recovery system that you decide to go implement must focus on this too. The other mistake that sometimes people make is to think of backup and recovery as a production thing. It actually needs to come in on day one with shift left. It needs to be embedded in your application. It shouldn't be an afterthought. It shouldn't have to be coming in later. So what that also means is self-service, dynamic provisioning for backup system, being able to express all of this as infrastructure as code is important. It's also important to prevent accidental failures. Everything's become self-service for developers. They ask for storage that's dynamically provisioned. They configure the data services, they add them, they remove them. But it also increases the risk of accidental data loss when there isn't a strict change control process in place. A misconfiguration could very quickly wipe out all volumes in your system. If that were to ever happen, you want to make sure that you're always protected, that there's a safety net below developers, that they can easily roll back these changes if deployment failures were to happen that were catastrophic. And we see this with customers, right? So this particular company has a large number of developers, lots of projects, lots of Kubernetes clusters running around. They have backup and DR requirements that are part of compliance. And what they look for in a backup recovery system is one that is easy to deploy via CI/CD. 100% automation, no UI needed. We have a great UI, but we also have the ability to support APIs. And we'll talk more about what that means later. And it's extensible for their needs. If they want to do something custom with Keycloak, they can do that. What the benefits that gives them is obviously increased security, increased compliance. They are with DevSecops. They are taking the time to take an application into production and hitting all the compliance requirements from 30 to 45 days down to 3 to 5, with future proofing for applications that come in, with a safety net that will gather any application that gets deployed in the system. So these are some of the things to think about when you look at shift left in these environments. And then finally, looking at what's another thing that's different, we need to look at what the operator challenges for some of the Kubernetes operators, Kubernetes admins are. One of the big things that we're seeing multiple companies and customers complain about is that it's not even a matter of money. It's just very hard to find qualified talent that knows and understands Kubernetes, because you have the combination of a rapidly expanding ecosystem and the ecosystem being relatively new. So as more people enter this, how do they quickly come up to speed? How do they perform critical tasks, both on the dev and ops side, without the risk of accidental or malicious data loss? It becomes increasingly important. The outlook has also changed from the ops perspective. Their business requirement now is to focus on the application first, not the different components. And in fact, there's no way to scale to that given the 100x explosion of application components we spoke about earlier. But more than that, it's about providing self-service. They need to be in the business of making sure the lights can stay on, but maybe developers can automatically do their own restores, can automatically set up backup policies. So this is important. The developer workflow is also changing. They'll deploy across multiple clusters. They'll deploy across multiple clouds. They might adopt new development or deployment methodologies such as GitOps. CI/CD pipeline is increasingly prevalent. So how do you automate this? How do you fit into different developer workflows without them having to change is extremely important for the operator of these platforms today. And then finally, nothing ever stands still in this ecosystem. The upstream Kubernetes pretty much releases every 3 months or so. So how do operators frequently upgrade? How do they have that safety? How do they adopt new features and deprecated features is again a challenge for operators given backup recovery is impacted by all of these things today. So to give you a more concrete example of how Kubernetes evolves today, first of all, Kubernetes, as I mentioned earlier, releases every 3 months or so. No official roadmap, bottoms up, driven by the special interest groups within Kubernetes. So it's a community-driven effort there. What it also means is that up till recently, all releases were end of life in 3 months or so. Oh, sorry, 9 months or so, and 3 versions after the previous one that came out. And what this again meant is as APIs got deprecated, if you're a year behind or so, how do you make sure that a backup from a year ago, if you need to bring back, how can you transform that into the new APIs that exist now? Fields have changed, fields need to be removed, etc. So that becomes critical. Looking at this diagrammatically, Kubernetes 117 came out early this year, 118 came out roughly a few months after that, and 117 entered just patch support, which wrapped up roughly 6 months after. And so when Kubernetes 120 comes out, 117 support would end. And when 119, which just is coming out or is going to come out soon, right? Similarly, you see that flow across releases. Now, the community is going to extend this to 4 releases, giving you roughly 12 months, but for an enterprise, that's still very quick. And what we see in the ecosystem is the majority of customers tend to be on a recent version because we have all suffered from upgrade pain in the past. And this is a scenario where it just makes sense to keep up with the most recent releases to get the best the community has to offer and to get the best of what the independent software vendors are building towards. So hopefully some of these factors give you a good sense about what is different here compared to virtualization-based ecosystems, how that impacts backup recovery. But some of the other things that we also need to think about in the data management space are even more critical. The first thing that I do want to talk about is data protection gaps. So there are a number of things that we'll see in the cloud native ecosystem that people from a VM or a traditional IT infrastructure already know, but sometimes that is being relearned in the cloud native space. There's often conflation of replication versus backup. People say, my data is stored in Cassandra and I have 3 replicas, but if one replica was to die, I have 2 other replicas to go for. This might protect against infrastructure outages, but doesn't protect against accidental or malicious data loss. If you have a ransomware attack as an example, what will happen is that the ransomware will spread as fast as your infrastructure allows it. If your application or your developer or an operator has an accident, they accidentally drop a table, for example, in a database, that drop will also replicate as fast as the speed of light allows. So these are the things that one needs to be careful about, that making sure you have an independent fault domain for your backups. Often today, Kubernetes is also being deployed frequently in public clouds. And people assume this is highly reliable infrastructure and the failure of my underlying storage is pretty much negligible. And the answer to that is no. Even cloud storage systems have annual failure rates that are, relatively speaking, much higher than 0. And so you will see failures in a year if you're running large-scale systems. And again, this is something to think about, make sure you're protected and covered there too. Another point to think about is that traditional tools that might have been available in a VM-based environment where you have a single lab to VM basis are not possible in a containerized environment. For example, freezing the file system. And this happens because it requires extra privileges that you don't want your container to have. So trying to do this will weaken the security posture of your system you don't want to. And therefore, alternate methods are needed at the application layer, freezing, etc., to be able to get the same benefits. And finally, containerization has delivered a lot of benefits, a lot of agility, but it also has introduced different layers. So for true backup and recovery, one needs to understand everything from the OS level when you're using container optimized OS distributions that might not have all the tools that you're used to, looking at the Kubernetes distributions. And even though they might all be certified, not all distributions are like. Looking at the application, which is distributed, looking at the database services, which are replicated, looking at networking, looking at security, looking at managed data services. You need to put all of these things together to protect your application as a whole. And obviously security top of everyone's mind, given all the ransomware that's running around, given all the break-ins we read about in the press, loss of data. And this is important because the Kubernetes ecosystem comes with a lot of things in place for you to help protect your applications. A simple example is network policies, where you might have your data service, say MongoDB, and that's running in your application namespace. And it's firewalled off from the outside world. You have a network policy that says only my internal application services in my namespace can access my database. Now, legacy VM-based products or legacy backup products might say, oh, poke holes in your firewall so I can get your Mongo at the storage that MongoDB uses to be able to extract data from it. But that is something you definitely don't want to do. Never weaken your security posture. If you look at Kubernetes native integrations, you can do it without any networking side effects or any firewall side effects. Authentication of your backup platform is again critical with the self-service point of view. So when someone logs into your backup platform, and I'm talking developers logging in, they just see their app, how it's protected, your restore points, how you bring those back. They can do all of that themselves via the API, dashboard, CLI. And you want to be able to give that, but that means you need single sign-on, you need different ways, the same way to authenticate to your backup and recovery system as the developer uses to authenticate against Kubernetes. End-to-end encryption is obviously table stakes today, but customer managed encryption keys are a must, split keys are a must. So when you talk about application portability across different clusters, this becomes increasingly important, as you don't want to hand out global secrets just per application or per restore point secrets. So how you do secret key management is extremely challenging for some of these environments. And then obviously you want fast restore, you want quick restore. This becomes critical for ransomware or accidents that might happen in your system, to be able to quickly bring your app up to what it looked like. And then finally, we're going to talk about ecosystem integration, right? The last major point I want to talk about, but this is super critical, right? Everything's important, but when you remember at the beginning of the presentation, we talked about the CNCF cloud native landscape. And yes, it looked busy, but a number of components that are key to proper operation of these platforms. And it is critical that one integrates against those from a backup and recovery perspective. The number of databases, including databases that we see are now optimized for running on Kubernetes, think Gigabyte, Vitess, CockroachDB. And for these scalar databases, we need to understand the structure, how they run within Kubernetes, have the right hooks to be able to quiesce them, to be able to back them up, to use logical tools. And there are a lot of challenges in doing that, because you can't just shut the database or replica down, because the container it's hosted in will disappear. So how do you do that logically is very important. But more importantly, the monitoring, the workflow, the ops workflow, how does that happen? If they're using Prometheus and then PagerDuty for alerting, if they're using Splunk or Elasticsearch or Stackdriver for logging, how do you plug into all of those components? So not introduce your own monitoring, your own logging, but delegate that via clean APIs to what the customer is used to is very important. And something that we again learned after talking to a lot of customers was about the APIs that a backup platform has to offer. You can always do REST-based APIs, but they don't work very well with Kubernetes. What we've discovered is that Kubernetes has an API extension mechanism called custom resource definitions, or CRDs. A backup and recovery system built for Kubernetes needs to have a CRD API. There are no ifs or buts around it, because what will allow you is clean role-based access control. You can do very fine-grained access permissions with that. No extra tooling is required, no extra user management, you can just cleanly integrate, have a much faster on-ramp. People use the tools they're already aware of, comfortable with, to integrate into this environment. And then finally, mobility and freedom of choice. When we talk about ecosystem, right, data management needs to focus on just that, data management. One shouldn't have to say, I need to get a storage system to be able to use a backup and recovery system. So if you're running in a public cloud, maybe you want to use EBS in AWS or Google Persistent Disk in Google. But when you're on-prem, you might want to use Pure Storage or NetApp. Customers should have the choice of picking what's right for them, what's best for them in whatever environment they might be in, or sometimes multiple in the same system. So how do you give them, A, the freedom of choice, being able to protect all of these storage systems, as well as give them the ability to say, if I want to move across storage systems for performance, for cost, for migration reasons, you have the ability to do so. So those become very important in this environment. Now, that's all I have to cover today. We covered a lot of information, and obviously you can never go into as much depth as one would like to in a talk like this. But what I will say is there are a lot more resources available online if you're interested in learning more. The number of white papers and ebooks, and these all vendor neutral. So I'd highly encourage you to go read these. And in particular, either if you're new to Kubernetes or if you're new to data protection, we recently published an illustrated book that looks at how cloud native backup and disaster recovery is different. And I am certain that you're going to have as much fun reading it as we had putting this together. So you can go download that today and get your journey started too. So finally, to sum things up, we talked about a number of things. We talked about how backup recovery, app mobility, disaster recovery are all coming under the same data management umbrella. Silos are collapsing. You need the same system to be able to do all of these. And do all of these in a world that's multi-cloud, that's hybrid cloud, where polyglot persistent is predominant, where you have multiple clusters, you have multi-tenancy, you have role-based access control. And data management in this world has to be purpose-built for Kubernetes. Ease of use is a big thing. We didn't focus too much on it in particular. It's increasingly important as the next generation of Kubernetes users enter the system. End-to-end security is a must in these self-service environments, and particularly in the world we live in today. And then there's the ecosystem one needs to integrate against. There's a rich ecosystem out there. One needs to leverage that. One needs to integrate against that. Obviously, at Kasten, we're doing a lot of this today. And feel free to check out our free version. There's a lot of open source software that we have. Check it out. It'll touch on and solve a lot of the challenges we spoke about today. But if you have other questions, feel free to drop me a note. You can find me on Twitter, this email, this Slack. So feel free to drop me questions. I'll be happy to answer them at any point in time and look forward to engaging with you more. Thank you, everyone.